Hi, I'm Sarah, and today we're gonna put some butter on these taters. Okay, so let's get started. On today's agenda, we're gonna be learning some basic kinematics. So first, this is V of F. Oh, hold on. I've just been notified that we are not here for physics. Oh, that's embarrassing. Well, let's turn the page. Oh, even better. We're going to be learning some integration by partial fraction decomposition today. We're going to start out with something simple, the integral of x over x squared minus 1 dx. So, first step, you always want to factor that denominator. And when you do that, you're going to split up the denominator into two parts, and you're going to say a over x minus 1 plus b over your x plus 1 of the denominator. And then, in this method that we're going to use, we are going to multiply. We're going to multiply by the common denominator, so that way we're going to multiply a times x plus 1 and b times x minus 1, top and bottom. So that way everything is going to have that common denominator of x squared minus 1, and that way you're able to say x is equal to a times x plus 1 plus b times x minus 1. And what we're going to solve for a and b. That is our main goal here. So first, we're going to set x equal to 1. And the reason we're setting x equal to 1 is that way, if you look over here, you can notice. When you set x equal to 1, you can cancel out that b and be left with 0 times b. So when you plug it in, you're going to get x is equal to 1 is equal to 1 plus 1, 2. So 2a plus 0b. So essentially, you're left with 1 is equal to 2a, and a equals 1/2. And then we're going to do the same thing again to solve for b, but this time we're going to set x equal to -1, so that way, when we get -1 plus 1, we can cancel out that a and be left with 0a. And when we do that, we get -1 is equal to 0a minus 2b. And then when we solve for b, we get b is equal to 1/2 as well. So then what we're going to do is we're going to go all the way back to the original, and we're going to plug in the values that we found. We know a is 1/2, and we know b is also 1/2. And when we do that, we're going to pull out those constants, and we're going to put them outside the integrals, and we're going to say 1/2 the integral of dx over x minus 1 plus 1/2 the integral of dx plus 1. And when we take those, we just know that we're going to be left with 1/2 times the natural log of x minus 1 plus 1/2 the natural log of x plus 1 plus c. We can never forget that c. It's a constant in calculus. That's what c stands for. And you'd think you're done, but according to your properties of logs, natural logs, that is, that plus means that we can multiply both of the things that are inside the absolute values, and x minus 1, x plus 1, x squared minus 1. And that is our final answer, 1/2 the natural log of ln x squared minus 1 plus c. Now, we're going to move on to something a bit more challenging. Oop, here it is. We're going to pull out some trig. We have the integral of cosine x sine cubed x plus sine x dx. And you're looking at this and you're like, oh my gosh, what do I do? Well, if you look really closely, you can see that the derivative of u over u is right here. So if you let u equal sine x, and the derivative of sine x is cosine x dx, then you have your derivative u and you have your u's going on. So it ends up looking less scary, and we have the integral of 1 over u cubed plus u, and I know you're dying to factor it. I got you. And we have the integral of 1 over u squared plus 1 du. And now we're going to break it up again, and we're going to say a over u plus bu plus c over u squared plus 1. It's bu plus c because the degree is to the second. So now we're going to move on, and we're going to multiply by our common denominator of the u times u squared plus 1, because we want them all to have the same denominator of u cubed plus u. And when we do that, we have our a times u squared plus 1 plus bu plus c times your u equal to 1. So what we're going to do is we're going to solve by substituting in again, and we're going to let u equal 0 this time, so that way we can cancel out this whole factor and solve for a. And when we do that, we are left with a times 1 is equal to 0 plus 1, so a is essentially equal to 1. There, that wasn't so bad, right? And now we're going to let u squared be equal to negative 1, so that way we can cancel out our a. And when we do that, we are left with a times 0 plus bu squared, hold on, we're going to get there, plus cu is equal to negative b plus cu, which is also equal to 1. And in doing so, we know that our u squared is equal to negative 1, so that becomes our negative b plus cu is equal to 1. And then when we solve for that, we get b is equal to negative 1. And then moving on, we're going to let u equal 0, so that way, that's how we got our negative 1. And if b is equal to negative 1, then c obviously has to equal 0 for that to be at work. So we have our a, b, and c going on. And then finally, we can plug our values back in, and we separate, and we have the integral of 1 over u plus u to the negative u over u squared plus 1 du. And then we take the absolute value. When we solve for the integral, we get the natural log of ln u minus 1/2 ln u squared plus 1 plus c. And in our final step, we're just substituting in back that u all the way from up here. And we have ln of the absolute value of sine x minus 1/2 ln sine squared x plus 1 plus c. And that's it. Stay tuned next time until we get to the meat and gravy.